Good morning, everyone. Thanks so much for joining. My name is Lindsay Moore. I'm the CEO of Developmetrics, which is a data science company that breaks down technology barriers to enable governments, NGOs, companies, and foundations to use deep learning to better drive development outcomes. And we work with partners to implement approaches like those that you'll be hearing about today. So in addition to our panelists, I'm really excited to be with this audience, and just looking right now at the attendees. It looks like we have ADB, ACDI VOCA, Amazon, MSI, GIZ, Optimal Solutions. We have the Foreign Commonwealth and Development Office, ECODIT, and so many others. So I just thanks everyone for joining. We're really excited to have you all here. And please go ahead and introduce yourselves in the chat. And we'll also be launching a couple polls to get your opinions throughout the presentation. And ask questions as you want in the chat throughout the presentation, and we'll do our best to get to them at the end. Those questions that we don't get to, we'll get back to you on. So we'll make sure everyone has an answer to their question. All right, so as we only have an hour and a lot to get through, I'm gonna just go ahead and introduce the roundtable. The goal of this discussion series is really to engage with the development community around how to most effectively harness the power of AI to achieve better outcomes in an ethical manner. And so we'll begin our discussion more at the theoretical level, and then we'll work our way down to concrete examples and best practices on the ground. So we'll be starting with Luke Jordan, who is practitioner in residence at MIT's Governance Lab. And he'll start us off. And Luke has worked in countries across the globe for organizations such as the World Bank and McKinsey, in addition to MIT, and founding 2 startups. So Luke, we're really lucky you found the time to join us. Next, we'll hear from Andrew Merlucci, who is a member of USAID's strategy and research team, which focuses on emerging technology and emerging trends in technology in the development sector. And Andrew also leads and implements the digital research and learning agenda under the USAID digital strategy, which aims to bring together diverse stakeholders around a shared set of research goals. And then we'll get to some more practical examples and best practices from Gloria Steele, who was appointed by President Biden to serve as acting administrator of USAID, and has had a distinguished career as a member of the US government's senior executive service for over 18 years. She was my boss as Senior Deputy Assistant Administrator for the Bureau of Asia, and also served as USAID's Mission Director in the Philippines, amongst many other positions. And Gloria is currently the COO at CARE. And finally, we'll end with Alicia Morris, a data scientist from Mercy Corps, who will close the conversation by providing us with some insights into her work with Mercy Corps to identify and implement new and interesting use cases for cloud technologies and AI. And her background is in conflict analysis and environmental modeling. So hopefully I covered your backgrounds. I had to cut them all short by about half, but feel free to introduce yourself. Well, Luke, I guess you have many believers in the audience. So let's start off with you and the big question. So how, if at all, can data science techniques help us forecast development outcomes?
Super. Well, first, thank you, Lindsay, for inviting me and putting this together. I'm going to just talk through a few results of a project that I've been doing with some colleagues at the World Bank's OPCS department on how to, on this exactly this question, on building data science techniques to predict project outcomes. Okay. So quick background, I'm going to talk through a project that was done as part of my residency at MIT's Governance Lab last year. It grew out of really thinking about what are constructive uses of artificial intelligence and machine learning. I usually use the term machine learning for democratic governance. A prior project had trained a model to predict municipal bond defaults with fairly high accuracy. And what we did was we started with examining the specific sectors of education, health, water and sanitation, or WASH, and then expanded them. And throughout the period we were focused on in this work as 1990 to 2015, and mostly MDG outcomes. So this is a project where we had 3 research questions. The first was, how are aid and outcomes related? And there we find a positive relationship, although a weak one. But then second and third, which I think is the primary interest today, Can machine learning techniques predict if a project will be associated with better outcomes? We are quite cautious about using any language to do with causality or other things. So the moment we're saying predicting a relationship several years later, the answer there is yes, positively, and I'll talk about some of the key steps that we did to do that. And then third is, to what features of the project does a model trained to do that pay attention, which we thought is the most useful from a practical perspective in understanding, can we inform what people, what actually matters in a project. And there, what's really important is contextualization. And we can actually now quantify this using modern AI models. Focus and the text of reviews. What was less important was single number project rating scores and loan sizes. So in terms of data, one of the things that made this project possible, and I'm sure is making a lot of projects possible at the moment, is the increasing amount of data available. We're not quite in the big data realm yet, but we're in the rich data sphere. So lots of projects available with more and more contextual information, more and more information and data on aspects of the project that are important, more and more text data sets available. So we primarily use 3 aid data, which is a well-known data set that covers, that aims for universal coverage at a fairly shallow level. Project performance data set compiled by Dan Hoenig and others that takes 20,000 plus projects from agencies that do M&E ratings and standardizes them. So that's been almost a decade-long project by them to compile that and make the ratings on them very standardized. And then we scrape documents. So the World Bank has a public archive and has in recent years significantly upgraded its ability to its OCR and other techniques for converting those into plain text. So we built a scraper and we turned that into a single data set, which is now publicly available, both on the MIT's Dataverse and in Hugging Face data sets for people who want to explore it more. The first thing that we did was, in understanding and applying the techniques that I'll talk about, we needed to understand what were the effects of controls and causal confounders on sector outcomes. So we went to the existing literature for this. We didn't reinvent the wheel. We found studies from the last 10, 12 years on each of these sectors: education, health, WASH, on the relationship between official development aid and the MDG outcomes of interest. And of course, in the MDGs, there was one outcome per goal. Subsequently, one of the reasons the SDGs are broader, but it makes it a little bit easier to run some of these. And we replicated each of those studies. This is not a replication crisis talk. The replications held. And what we found in all of them was that aid was significant, but the coefficient sizes were modest. So doubling aid per capita usually led to about a 3 to 5% increase in these outcomes, with the caveats that we're comparing flows of aid with stock outcomes, and that a lot of projects in aid might not be targeting exactly these outcomes, although that's something we'll come back to. Outcome ratings, when we inserted them here, were only significant for fiscal management. They were not significant in the other sectors. So then getting to the interesting bit, and again, apologies sometimes for the speed. What we did is the part of the project was to apply what are starting to be known as EconML techniques on these sector outcomes. And that's really a 2-stage process. So stage 1, partialing out. We took every World Bank project in health, education, WASH, and then extended it to energy and fiscal. And 5 years after that project was finished, we predicted the outcome in its sector using all the non-aid factors. We then subtracted those predictions from the outcomes, so that what we were left with was a residual outcome. That residual outcome had the advantage of, one, having netted out a lot of country characteristics, income levels, institutional quality, etc., and was unit free, so we could combine across all of these sectors. And what we were looking at was a project versus the residual outcome in its sector 5 years later, after the project ended. What we then did is we then applied a battery of standard machine learning models. So we generated feature vectors, added embeddings of the project documents, which I'll talk about more in length, And then we went through a standard sort of machine learning model fitting process to find models that could predict, given a project and its features, what was the outcome, the residual outcome in its sector. Now, the one key step that we did was we generated as an input to this contextual embeddings of all of the World Bank project documents. So that's at approval stage and at review stage. Specifically, and again, I'll come back to it, we used the modern generation of transformer models to generate sentence embeddings based on similarity matching scores. And we then did a dimensionality reduction just because of the size of our data. But long short, we basically turned every project into a two-dimensional point on an abstract plane, as we have here, that naturally sorted itself into different sectors. And what that embedding captured is the contextual interrelationship of text within the document. Again, something to come back to, and something that is a little bit of a black box. But the one thing that we can say is, one is you can see sorting into different sectors. And when you apply this process to health projects, for example, for 30 years, they're all in the same place with very similar variance in where the embeddings land until you hit 2020. And then all of the embeddings completely shoot to a different part of the graph and the variance collapses because, of course, every project turned into a COVID project. So these embeddings were one of our key inputs. And using them, as well as a few features engineered from them, we're able to get fairly strong results. So two things that we were able to do is we looked at it at approval. How much can we predict when the project is just coming up for approval? And then how much can we do it at review? And we looked at two things. Obviously, from a machine learning perspective, the thing that's important is how well does it predict projects that it hasn't seen before. So we get a ROC AUC, a robust measure of accuracy at approval of around 70 to 72%. And how much variance can it explain, which was important because we looked at other literature looking backwards, and there it's about 55 to 65%. As a comparison, the previous literature on this using standard linear models, regressions, etc., was able to predict at most 25 to 30%, and the label there was the ratings, which we know usually are not actually significant. So this was quite a significant step up. And a lot of it depended on non-linear models. In the end, our best performing model is an ensemble tree. But the one thing that's clear is all the non-linear models significantly outperform linear ones. So in terms of what we then really wanted to understand is, what do the models consider important? So we used SHAP feature values as well as other techniques to understand what were the models learning to pay attention to. The dominant features are the embeddings of project documents and what we call the distance to the country and sector mean. That's contextualization. Very briefly, what we did was, for each project, we took the distance between the embedding of the project's document and the mean for its sector for that decade, which basically gives a measure for how much has it diverged from global standard project documents to incorporate country knowledge, and then how much has it incorporated sector knowledge into a standard country project. So that tailoring to context and project focus mattered the most. What tended to be less important, either the middle or the bottom, were either loan size or some of the things like project team experience and financing instruments. Of course, conditional on the other things. So as I say, that's a lot because we have a lot to talk about today. There are longer section versions of this where we say about possible future directions. One, we're continuing to expand this, continuing to discuss with different teams about using these results to improve processes. For example, using the text embeddings and the model score in general to early detect cookie cutter projects or improve rating processes. Sometimes for the public, we might create a should my country take this loan.com to make the project, the model deployed and publicly available. We also think in terms of other researchers, these data sets are now public. Obviously, AData and Dan Hoenig and his colleagues have made their data open for a long time. We've put the World Bank projects open. The embeddings that we generated are also publicly available. So we're hoping that lots of people explore this. Right after we did this work, a team at Stanford did a very similar kind of methodology with fantastic results in predicting salaries from job ads. This basic combination of very modern kind of recent embedded text embeddings plus nonlinear models seems to be a methodology that's being very productive in a number of ways. So a lot can be done and encourage a lot of people to do it. It does generally require Python instead of R. But we think there's a wide array of techniques that are becoming available, and would encourage everyone to explore, plus ask questions. So conscious that I went through that quickly, but I'm around for questions and answers afterwards.
Amazing. Thank you so much, Luke. I mean, you've really been an inspiration to a lot of us and us at Developmetrics as well, applying these kind of techniques to USAID evaluations. And I love your idea about should I take this loan? It's really, really fascinating work. And I know you had to really get a lot in just short time. So we'll also be sharing Luke's presentation at MIT, which I believe is at least an hour and really goes more into his methodology. But we have a wide audience here, so we now want to slowly bring it closer to the ground. So we'll next go to Andrew Merlisi. And Andrew, I think you're going to talk a little bit more about what USAID is doing, and I'm really curious about how is USAID thinking about machine learning in the context of the digital strategy, and as well as any kind of interesting use cases that you're aware of.
Yeah, sure. Thanks, Lindsay. And Luke, yeah, really interesting work. I think this is fascinating. You're thinking about how to use machine learning to evaluate the impact of development projects, development programming, and the things we're thinking about at USAID are both that, but also how can we use machine learning in our programming, and also how can we kind of respond to the fact that machine learning is used in the countries where USAID works, and increasingly so. So yeah, as Lindsay mentioned, my name is Andrew Merlisi. I'm a Science and Technology Policy Fellow at USAID in our Innovation, Technology, and Research Hub, or the ITR Hub, it's called. And our team works on emerging tech and kind of emerging trends in technology in the context of global development. So we've put out a few publications recently about machine learning and development. We have a number of projects in the works, one focused on gender equity or gender inequity in machine learning systems, as well as a kind of global challenge to help advance computer science and data science curricula to better incorporate responsible innovation as a kind of key component of the curricula. And more broadly, the ITR Hub where we work covers a wide range of technologies. So we're talking digital inclusion, digital finance, data and informatics, cybersecurity, geospatial tech, emerging tech, as I mentioned. And then, of course, the kind of responsible innovation and research components of all of those things. So I'll talk today, as Lindsay mentioned, just about a few points about how USAID is approaching machine learning. So, surprising no one here, the kinds of norms and ethics and best practices around machine learning are still taking shape, domestically here in the US, but of course, globally as well. And so we're working to, kind of think about how machine learning tools are designed, how they're deployed at the global level, to kind of ensure that they're deployed in the interest of serving those who could benefit from them the most. So just a few examples. I mean, yeah, Lindsay, to your point about where we've seen kind of promising examples of machine learning, kind of across sectors, and I'll name a few, but in global health in particular, USAID has historically supported digital transformation of health systems, and now kind of one more recent component of that is using machine learning tools that can do that. So, one example, we've seen how machine learning can better predict, which with patients living with HIV or tuberculosis who might need extra follow-up care to ensure they're remaining on medications and following up with clinics and that kind of a thing. And machine learning can be used to kind of better target those services to people who might be most at risk of falling out of treatment. Of course, also in global health, this is sort of a canonical example, seen machine learning used for demand forecasting for, in supply chains. In one case, we've seen in Cote d'Ivoire, supply chains for contraceptives and health service delivery. In democracy and governance, we've seen a project is actually just released a little while ago from Duke University, a cooperative agreement with USAID to see how machine learning can be used to kind of mine text from news articles throughout the world and forecast closure in civic spaces. That's a really interesting project. I'm sure there's going to be a lot more work done there. And then, yeah, of course, among the many examples we could talk about, we've seen machine learning be used to match qualified candidates with jobs and in areas where there might not otherwise be a good connection there, or where candidates might not have the kind of typical, work history or education history that would align them with particular employment opportunities. And then, separate from that, separate from the applications that we could use in development, we also know that machine learning tools have been used for repression in a lot of the countries where USAID works, or even, more innocently, just sort of unintentional misuse of machine learning technologies that can, entrench social and economic or political inequity. So facial recognition technologies are a classic example here, used to surveil and oppress minority groups or political opposition, maybe. Machine learning tools can give unequal access to goods or services to people of different genders. So we've seen this with credit scores, for instance, where women might receive systematically lower credit scores compared to men. And then the last one I'll talk about just briefly is, minority languages not being represented in digital form, or maybe languages that are typically spoken but not actually written down. Those are the kinds of things where there's inherently going to be a dearth of data on those languages, which means that kind of machine learning tools we might want to build for translation and that kind of thing are gonna struggle there. But of course, the kind of second piece that I want to talk about here, separate from things in our programming, how we might use machine learning now or aspire to use it, is just the fact that they're embedded, like all technologies, in the kind of digital ecosystems in the countries where we work. So this is why the sort of second component of the USAID digital strategy is to invest in digital ecosystems. And that means, making sure that they're open, inclusive, and secure, and really building up the kind of overall ecosystem kind of infrastructure to enable responsible use of tech. So this is just like a couple of examples, right? Like without strong data collection or data storage practices, we could have leakages of the data used for machine learning systems that could threaten basic rights to privacy. Without strong and independent judicial systems or civil society institutions, there might be no one to hold machine learning systems to account, for errors they might make, or for, as I mentioned, like misuse of them. And then, of course, without government policy, we can't ensure that machine learning systems are deployed in a way that respects human rights. So all of those things are, ideas and ideas that USAID is kind of actively working toward under the digital strategy and under the digital research and learning agenda. And I'm happy to share a link to the digital strategy, or our recently released digital ecosystem framework, which talks about all of these kind of ecosystem factors that we want to put in place, or digital action plans, which are sort of more sector specific things that USAID wants to do related to digital tech, machine learning included. But I guess a few things that we're kind of prioritizing at this time. So the first is, using machine learning responsibly in our programming. That means, prioritizing it when it makes sense, but also more kind of systematic exploration of the kind of risks and rewards across our programming. So that means investing in our staff capacity to do that research and kind of understand these tools and be able to deploy these tools, and all of that under the banner of kind of harnessing it where it makes sense for improved development outcomes. The second is, as I mentioned, strengthening digital ecosystems. So that's investing in digital data infrastructure and data governance capacity in the countries where we work, strengthening accountability and oversight, promoting responsible kind of computer science and computer science workforce and education, as I mentioned. And then the last is kind of using partnerships as a way to shape global policy about these ideas. So that's both on the research front, certainly, like how can we work together to better, certainly not duplicate efforts, but also just better harmonize where there are, particular strengths of people working in this space. And then lastly, kind of, making sure that we're elevating the importance of including developing country actors in the kind of global decision-making fora or policy setting fora around these topics. So maybe I'll wrap up with that, but yeah, happy to take questions afterward if anyone has any. Thanks.
Great, thank you so much, Andrew. And I feel like every speaker could speak for an hour rather than 10 to 15 minutes. So I really appreciate you, and we'll definitely follow up and have more time to speak in the future. But I just, it's really fascinating to see how USAID is being such a leader, thinking through AI applications to development and taking this ecosystem approach. So I'm looking forward to following your team as you implement this strategy. I think it's pretty exciting work. So thank you for that. And so now we get a little bit closer to some practical examples with Gloria Steele. Thank you so much, Gloria, for joining us. So I want to know, given your distinguished career in international development, can you tell us about some best practices and examples you've seen when applying data science to development projects?
Thank you very much, Lindsay. Good afternoon, good morning, and good evening to everyone who has joined us today. Thank you for inviting me to this panel and for organizing this webinar. It comes at a particularly important time when we're all seeking for ways to improve the effectiveness and the impact of development and humanitarian programs all over the world. I assume that most, if not everyone in this virtual room is a development practitioner. And as such, we all know how critically important data, good data that is, in designing projects, in ensuring that projects achieve their intended impact, in detecting when a project is just not going to achieve the outcomes it was designed to accomplish, and in learning from our projects. And I'd like Lindsay to share my reflections really on how data has been used or not used and where they can be used. And as you asked for best practice, I'd like to go into that too, but try to keep this in 10 minutes or less. The question is, we all know all this, how important data is, but how many development practitioners systematically use data to drive decision-making and learning? Thanks for the poll that was taken. And I think it indicates how many and to what extent, but why do we hold on to conventional wisdom that has no empirical data supporting it? Really quite frustrating. And why do we continue implementing failed projects, hoping for a better outcome next time around? The problem is not really the lack of data. Luke's project focused on data going back to 1990, and the World Bank archives include data going back to 1947. I know that other development organizations carry volumes of data that can support effective programming and decision-making. One of the reasons over time that I have observed is perhaps the preponderance of unwieldy data. We all know how much big data analytics and AI have revolutionized every industry, from health to education to finance to marketing to logistics and others, by making data more structured, more accessible, and more usable. Their application in international development, while not as far along, has great potential to generate equally transformative impacts. The work of organizations such as Developmetrics will contribute significantly in advancing the use of data science and AI to improve decision-making and international development. And Andrew, I'm really excited to see how much work USAID is doing to advance this. And today we heard about Luke Jordan's project, which used machine learning to predict the outcomes of education, health, and WASH projects. Predictive analytics have great potential to accelerate and better target impacts of development and humanitarian programs. Prior to the advent of COVID-19, significant progress was being made by countries all over the world in achieving the Sustainable Development Goals. Sadly, the pandemic reversed much of the hard-earned progress, especially in key areas such as poverty alleviation and food security. With needs significantly outpacing the supply of development aid, the ability to predict development outcomes through big data analytics and machine learning could be a significant boost to development partners. Humanitarian crises have been growing in number, intensity, and duration, largely because of conflicts. In turn, conflicts have resulted in extreme poverty, food insecurity, and in many cases, gender-based violence. Billions of international development dollars have been spent in programs to resolve conflicts, but there's not been much of any recorded success, as far as I know, in development efforts resolving conflicts on a sustained basis. I am hoping that data science or machine learning will be able to provide insights on sustainable conflict resolution interventions. I would love to see that, Lindsay, if you have information on that, or look, if you would go into that. I think that would advance knowledge and learning to a significant degree. The application of data science to identify interventions that can have significant impact in fostering women's economic empowerment and improving agricultural, education, health outcomes would be most welcomed by project designers and funders. Through AI, it may become possible for countries and development partners to launch timely and proactive actions to prevent extremism, disinformation, pandemics, food insecurity, gender-based violence, and drought through early detection. So Andrew, I really applaud the work that USAID is advancing in the use of AI and machine learning for early detection. According to an article written by DAI Global, the combined use of data resources, small-scale surveys, and machine learning could replicate more traditional surveys that are used in monitoring and evaluation projects. This can have very important implications for reducing the cost of acquiring data and making data more accessible for development planning purposes. In summary, exciting development in big data analytics, data science, and AI have great potential to accelerate the impact of international development and humanitarian efforts. As data becomes more easily accessible and less cumbersome to use, let me end with one best practice, which is to underscore what Andrew had already said, to ensure the importance of equality in data access, ethical use of information, and respect for privacy. Again, thank you, Lindsay, for organizing this webinar, and congratulations to you on your leadership in advancing the use of data science, big data analytics, and AI to improve the planning and decision-making in international development. Thank you.
Thanks so much, Gloria. That was really a call to action and provocative, as you always are. But you've always been unrelenting in your need for data and data to inform every decision you make, and that's always been a huge inspiration for me. And I know you're very concerned about the use of data in conflict situations, and there's really a call to action for all of us to really look deeply into that data to see what's there and how can we improve future interventions. So thank you so much for your leadership and for being an outspoken voice on the need to not repeat the same errors over and over again. So really appreciate your leadership and keeping us looking at the data. So thanks so much, Gloria. Okay, great. Well, we're going to end now with our last speaker, Alicia from Mercy Corps. Thank you so much for joining us and bringing us a little bit more to the ground level. So now that we've heard so many good examples and we're clear on the methodology to get started, can you tell us about some practical challenges and barriers for starting data science efforts for those organizations who are interested in engaging now?
Yeah, thanks so much for having me, Lindsay, and for organizing this discussion. I'm really fascinated by all the work that's being done in this space and by the previous speakers and all the great contributions that they have to this space as well. With respect to sort of challenges in actually moving an organization, like Mercy Corps or our other type of humanitarian and nonprofit organizations into sort of that data science space, how do we get data science moving in our organizations? There's a lot of challenges. As you can imagine, anything in the nonprofit sector is under-resourced, and there's not enough time, not enough people, not enough money, as always. So we can skate over that and just assume that's a baseline for everybody. But there's really, I think, like 3 bigger groups of challenges that face kind of a wider organizational adoption of AI ML technologies. And those 3 groups are people, tools, and data. with respect to people, one of the biggest challenges is that the people that are actually designing and implementing programs on the ground, that are where the rubber makes the road, people who are making daily decisions about program design, program continuity, program adaptation, they need to be able to receive what can be very complex results and then interpret and apply those results in a practical way. So there's, I think, a bit of an education gap in sort of understanding how do we take this information and really apply it to the problem that I have. And for the most part, our implementers, our folks that are on the ground making those decisions every day are brilliant people who have deep contextual knowledge about the area that they're working in, but they're not necessarily quantitative experts. And this is, I think, changing. I think more and more folks are coming in with more of that background in some of this quantitative space, but we can't necessarily rely on that yet, right? And that's not what they're meant to be. They're meant to be contextual experts. They're meant to be local experts and have experience in development. So there's a little bit of an education that needs to happen with those folks to really talk about what do these results mean and how do they apply to this specific situation. So even if you build these beautiful, complex models, if those results don't make sense to the person that has to make a decision, then they don't do anyone any good. And I think part of that is also emphasizing that we can create as many models as you like, and they can be as accurate as you like. But at the end of the day, that decision can't be based solely on a number. It has to be also based on your knowledge about the space and the specific implementation that you're interested in. I think that's important to emphasize because I think our development and aid programming is about people, and we start to suggest you might take people out of the decision-making loop. That's really uncomfortable for a good reason, right? These situations are complex, and we can't just rely on machine learning to answer these just insanely complex system dynamics that are occurring every day. The other piece of that is that there's a super strong emphasis on local action and the application of sort of aid and development at the local level. And I think there's a perception that having sort of an aggregated piece of information is less useful or perhaps not useful at all. So we really need to have really close collaborations with our country teams so that we can understand how specific contexts differ and how results could be applied for decision cycles in those specific contexts. So it might be different even within the same country, region to region, how those results could potentially apply. And again, that's something where we can't just provide results and call it good. We need to really have a deep collaboration with those country teams, and that requires a certain bit of education on an organizational level so that we can have productive discussions in that space. And then the last one is that in terms of people is that the perception is that we just don't have the skill sets that, not every team has a data scientist or even a data analyst. Often sort of the most quantitative person is a MEL expert, monitoring, evaluation, and learning expert. And they're not machine learning experts or AI experts. And so there's sort of this perception that like, we don't have the right people here to do it. But I think we need to really look at how we collaborate as a sector. There's a lot of brilliant minds out there who are building models every single day. And a lot of those models are open source and available to us. So we could go out and get the code from that model and plug it in somewhere in the cloud and be generating results. A lot of data is open source. A lot of people are interested in collaborating, and it's really going out and finding those points of collaboration. So we're not doing all the data science ourselves. I don't think like our focus should necessarily be on doing all the data science ourselves, because that's not, Mercy Corps' role in the world. There's certainly lots of academics who spend literally years of their lives developing these models, and I'm not going to do it as well as they do. And I'm certainly, I've got my hands in so many different sort of like things that like I really can't give it the time, attention, and research that it needs. So relying on folks like Luke Jordan, who's much smarter than me, to do the research and then provide me some open source so that I can create implementations and then use those results, I think is another piece of this, is using data science as opposed to creating data science all the time. So talking a little bit about tools, I think the other perception is, we don't have the skill sets, but also like we just don't have tools and compute power. I have one analyst who sits in Beirut and he's trying to, do our modeling on his laptop. And that's not like an effective or efficient way to do widespread data science, right? So what we've done at Mercy Corp, we've really leaned hard into the cloud to sort of enable the use of data science, right? And so when I talk about going and getting open source models and plugging them in, we have a very generous partner in Amazon Web Services. And so we have access to their platform. And that's really where we're going. And we're saying, how can I plug this in to a platform like AWS and create an implementation of model that's now generating results for me, right? So again, we don't need to build these custom models, but we can use the cloud to do that. And there are other tools on the cloud that enable sort of the exploration of data science for folks that aren't necessarily data scientists. Tools like AutoML, you know, Amazon has SageMaker, which has some really interesting sort of automated ML technology incorporated with it. We actually use a forecasting tool on that platform to do price forecasting for some countries. It's just a time series forecast, particularly in contexts that have big inflation events occurring. That's been an effective and pretty accurate method for us. So looking at some of those tools that don't require necessarily hands-on keyboard writing that Python script every day, that it's a little bit more click and play on the browser window instead. And then the last thing is that how can we kind of like meet the analysts that we do have where they're at and enable their data science in the context in which they can do it, right? So I think Luke mentioned we've got to do a lot of stuff in Python, not R. We're making that transition. You know, but if all you've got is somebody that's coding in R, how can you meet them where they're at and enable that greater access to cloud compute power, right? So we look at things like translation, but also containerization. You can make an R-based image in a container and run a model that they've created in the language in which they've created it, doing that collaborative data science. So I've done some things where I'll do the forecasting bit of it. Let's forecast the prices. And then I have an analyst who then does the econometrics bit of it and translates that to something like an affordability analysis. You know, how many people are going to be able to afford the food basket in 4 months? And so we're really looking forward to kind of our future-facing data science efforts, which are further exploring applications of data science for semi-technical people. So what do our workflows look like where we're using things like off-the-shelf analyses, like what can be replicated quite easily, where it doesn't take a new data scientist to do all the research and application for that context. But we know, you know, generally what contexts this model might apply to. You can make some easy changes and then extend that model or expand that model into a new context. Also things like Jupyter workflows where people can easily see code and then output code and then output and can start to learn some of these data science processes are something that's we're exploring. And also, you know, just things like data access, making sure that folks have the opportunity to play with data. You know, that's a huge one. And that's a good segue into sort of my last thing, which was about the data itself. I was really happy to hear Gloria mentioned something about making data more structured and usable. So I think sector-wide, this is a lesson that we all need to start thinking about, which is that there is information out there, but oftentimes in the humanitarian aid sector or the development sector, that data is published in like a standard nobody understands. It's published, you know, if I get an Excel workbook as a data product, like that's probably not the best way to publish your data because it makes it very difficult to access programmatically. So it really limits, it increases the amount of work that I have to do to manage that data in the first place. So really starting to think about, as a sector, how do we publish data, I think is super important. I would say 70% of the work that I do for our teams has nothing to do with actual analysis, but has everything to do with just engineering pipelines to make sure that there's not somebody on the ground sitting there for days on end trying to get data into the right shape so they can do something with it. Because what ends up happening is just nobody uses it and it sits out there on the internet. So again, leaning into the cloud to automate processes, but the first part of that is really looking at what are our data quality standards as a sector? How do we want to make data available? How can we make data more available? And how can it be more usable? Not just available in its raw format, but usable in an analysis, I think is a super important conversation to continue to have. So those I think, like I said, are the three big buckets of challenges that you see. There's a lot more. But yeah, I'd be happy to answer anybody's questions about what we're doing at Mercy Corps or other things that we've seen in our exploration of implementing AI/ML as well as cloud technologies at our organization.
Thanks so much, Alicia. I love your points. I mean, that's a lot of practical examples, but I think also just your emphasis on the need to make data usable is something we share. And we really appreciate kind of Mercy Corps' openness to play with us with data and explore the various ways that it can be more usable. You know, I really relate to your point about how information needs to be more readable. You know, at Developmetrics, we've coded the universe of development documents, and it's painful. It's really painful. So it's great to just have that information out there if we can make it, you know, more readable, more usable, and more you know, interpretable for those people that are actually making the decisions. I think that's really, really important, and I appreciate your work on that. So I know we have a hard stop in 10 minutes and a lot of questions coming in. So Ali, I'm gonna pass it over to you to ask some of the questions.
Sure, perfect. Before asking the questions, I would like to clarify that because people were asking from the chat, all the data that Andrew shared and our recording and Luke's presentation will be shared with you all. I will send an email personally. And regarding the paper, like Luke's paper, it's not finalized yet. It's being finalized, and it will be ready maybe by the end of this year. So let's go to the questions. I think the one of the questions Alicia already answered, so I would like to direct it to her again. How can data science be accessible to everyone, especially low and middle income countries? We have a question from Rula.
Yeah, that's a great question. And yeah, I think I talked a little bit about sort of just accessibility, but I think the first thing is, you know, if you're trying to look at like, how do I implement something like a data science program in a lower sort of income country? The first thing is look at like the costing of different types of resources. So I actually have a presentation floating out there somewhere. I'm sure we can share the link that I did with AWS about our strategies for using managed services at low cost to deal with data. And so there's some tools, for instance, on AWS that are designed for big data. And so if you don't truly have big data, which almost nobody in the development sector does, you can almost use those tools for virtually free. And so that's an important thing to keep in mind, is that you really need to dig down into what's my actual use case and what's the costing of this stuff. And then also, you know, as I mentioned, there's a lot of stuff that's open source already. So using data science instead of creating data science is another great strategy for that. Things like R and Python are open source tools. You don't need a license to, you know, go out and get that programming tool. You do need a computer. So that can be, you know, like a challenge even sometimes in some of the places that we work. But certainly, you know, there's relatively low cost barriers. If you're just talking purely about the financials for getting into it, you know, there's ways to kind of, you know, make it low cost for you. So that would be, I think, like my big thing is actually look at the costs and then calculate out how much compute power am I actually needing here, and you'll find things like cloud space is relatively affordable.
Amazing, thank you. If anyone would like to contribute more, or I will go to other question. Yes, please, Luke.
Yeah, I mean, I just like to echo one of Alicia's things, and to add, I think on this point of data is, you know, there is nothing quite like getting your hands dirty, working with data and doing some feature exploration and so on. So I'd suggest that one of the things is make data more available, publish problems that people are looking to get solved, and then making it very open for people to actually go and get hold of that data, start working with it and contribute back to it. Because actually a lot of people in low and middle income countries with access to a decent laptop and some notebooks, given the size of the data sets, you know, who are passionate about this, can contribute a lot and gain a lot of experience, but they need access to good, well-structured data, like good problems that they know that people are interested in, and like channels to come and contribute back. So I think putting that in place can also do quite a lot.
Thank you so much. Indeed. And since we have 6 minutes left, I would like to take a question from another person. Prakash asking, digital governance is becoming a big problem. How we can resolve this problem and ensure ethical use of data? So maybe Andrew and Luke, Gloria, actually it is more generic question, so you could all talk.
Yeah, I can say a couple things about that. I mean, there's probably, there's not one answer here, right? Like there's a number of different angles you could get to that, the answer to that question. I think maybe a couple that I'll mention is just in terms of the pipeline. So like I mentioned this project that USAID is working on related to a challenge for developing computer science curriculum that is kind of inclusive of this responsible innovation approach. That's one sort of way to get at that, right? Like if you have the people who are building these tools, deploying these tools from a very early age, so very early in their career, sort of an understanding of the kinds of ethical issues that are likely to arise with these tools. That's one way of kind of instilling that culture very early on. Another is like the more kind of outreach to decision makers throughout the world. So just one example of this, our colleagues at State Department are running a program where they're basically bringing together people who are kind of influencers across the world in the technology space, and hosting workshops with them, doing kind of like sharing among all of these different actors in all of these different countries throughout the world, very much getting at this question, like how can we better structure governance issues around data and around machine learning in particular, to make sure that policymakers are really up to speed on the kinds of issues they should be thinking about. What are the kind of nascent policy ideas that are coming out that seem really effective? Those are the kinds of things. I mean, and that's as simple as conversation, right? Like that's as simple as sharing information between people on things that have worked before. Those are just two ideas.
Amazing, thank you. Already you gave just quickly 4 different ideas. It was amazing. It was awesome. And Charles is asking a question.
Ali, I think Gloria had
Oh yeah, please, Gloria. Sorry about that.
Well, I was going to add to Andrew's response, a growing area of development assistance is in promoting good governance. And as development practitioners, development agencies and organizations get involved in promoting good governance, they need to include digital governance as part of that, because it has implications across all sectors. It has implications for promoting economic growth, democratic institutions. It has implications in the health sector, etc. And so another call to action, Lindsay, as organizations get involved in the area of good governance, it is really important to include this. Thank you.
I think that's a great place to end with Gloria's call to action. She's cut our work, Gloria. I feel like I work for you again. We all have a lot of work to do. Maybe Luke and Andrew and Alicia can help us out. But I just really want to thank everyone in the audience for attending. If you have any questions on how to implement these approaches or questions for the speakers, please reach out to us. We are happy to help to the extent we can. And Luke, thanks for sharing your notebook online as well, as you were saying, the importance of having open data. Luke has a lot of great resources that you can follow. So thanks so much to everyone. It was a great discussion. We'll follow up with another discussion next month. And I just want to thank all the speakers and all the attendants. Thank you so much, everyone. Have a good rest of your day. Happy Friday.